Okay, I've started recording and I am sharing my screen again. Okay, so first problem for the day is delete leaves within, to begin with, we have three problems to discuss today, two from the medium bucket and one from the hard bucket. We'll start with the first one, that is the medium problem. The first problem goes with delete leaves with a given value. The problem is you have been given a binary tree with the root node and an integer target, okay? And you have to delete all the leaf nodes with the value target.
Okay.
Note that once you delete a leaf node with the value target, if its parent node becomes a leaf node and has the value target, it should also be deleted. So you need to continue doing that until you don't have any leaf nodes with the value target. So they have given an example here with a root, with a tree with root 1, left child 2, 3, and the target is 2. Okay, so first we go to the leaf node. Okay, you see 2, so you delete this node, so you reach this step. You also, so both the left child basically. Then you reach this node, which is also becomes a leaf node, this 2. So again, delete this leaf node. Because this is a leaf node with the value as target, so we'll delete this node as well. So you're finally left with 1, 3, and 4. None of these nodes have has a child, or a leaf node rather, which has the value target. So that is why this is the output. There's one more example, example number 2, where you have 1, left child is 3, 3, again left is 3, and right is 2. As you can see, this 2 is the child, is the leaf node, okay, which with value same as the target. So we will delete this node. Okay, so we are left with 1, 3, 3, and 3. Oh, sorry, I'm so sorry. The target is 3 over here. So you delete the 3, which is the child. So you're left with 1, 3, and 2. You don't delete this 3 node over here because it still has a right child. So it is not a leaf node. Hope this was clear. There is another example with again target as 2. So you delete this leaf node here. You come to this child 2, even this is a leaf node. So you go further ahead, then 2 again, and then you're left just with 1. So anybody who has, I think the fourth example is similar, where you delete all the leaf nodes with 1 and you are left with nothing. So anyone who has attempted this problem? Any lead on how you have solved it? No one solved this problem?
So let me see. We cannot make a decision to delete a node, you know, unless we know we already processed the children. So
right.
That would tell me that you know, we need to do the post-order traversal, because to post-order traversal, we process the children first before we process the node.
Yes.
So let's see if we and we see if the children, if both children are null and the children value is equal to target, then we can delete this node and return null to the parent.
Yeah, I think.
So kind of you do the recursive post-order traversal.
Okay. So in that, so let's see what you just mentioned in example 1. So with the post-order traversal, you will come to the leaf node 2, which is at the n, this one, oh sorry, the last one, and because you did a post order traversal, so you go to the children, to the last child over here, and then since this value, left, right, okay, so since this node is the target, so then you'll delete this node, and then you come back to the parent, okay, recursively. Over here again, you see, so since this became null, the left and the right both are null, so this becomes a leaf node, and then you delete this as well. That sounds correct to me. Has anyone else solved this problem with any other approach? Can this be solved iteratively?
I use the BFS to solve this problem.
Okay.
Yeah, and I also create a map to find each node's parent is the key of the map, and the value is its child of that node. And to use the BFS to iterate level by level. And if we reach the leaf node and the leaf node value is equal to the target, and we delete it and define the parent node and put the parent node back to the queue. Yeah. And while the queue is not empty, we do it recursively.
Okay, so you are still using recursion.
Yeah.
There. Okay.
I use iteratively. Yeah.
So what are you storing in the map? Sorry, I didn't get.
Okay.
That.
The map is to store the parent of the node. For example, the example 1, the root node is 1.
Right.
The map key is 1, and the node 1 has 2 children. One left is 2, and the right is 3. So the map is value is oh no, the key is the child node, and the value is the root node. Yeah.
So you said the key would for the map.
Yeah.
What will be the key for 1?
The key for 1 is the key is the child node, and the value is the parent. For example, the key is the 2, and the value is 1, and another is 3 is the key, and 1 is the
Okay. Okay. I see. So then, can you repeat the your algorithm again?
I use a BFS to have a queue to put each node in it, and
okay. So you are still going level by level from 1 and then 2 and 3.
Yeah. Wait for a moment.
Are we?
Yes, I create a queue and put each node to that queue.
Okay.
Put the root to that queue, and I popped out. And if the node is not the leaf node, we continue to put the left and the right to the queue. Else, if the node is a leaf node, I'll find the parent of that leaf node.
I see. Okay.
Yeah, and remove the leaf node and put its parent to the queue.
So let's say let's say that we at node number 2 on the second level, right? And the parent is the. So now we go to the third level. We see number 2, which is, and this 2 is the children, a child of the other 2. So now you see that this 2 right here is a leaf node, and then you delete this one, and you say that you find a parent of this node and put it back to the queue.
Yes. Yeah.
But this is already in the queue, is it? Or you already removed it? I missed that part.
Yes. Yes. The second level 2 is already queue, but I still put that parent to the queue.
Okay.
Yeah.
Okay.
So I think, you put the parent back to the queue. Okay.
So first you remove the parent and put the children on the queue, and then later you find the parent and you put it back to the queue. Okay.
Yeah.
But then, okay, but you have to set, you set the parent left child to know first, right? Before you put it back to the queue.
Yeah, I popped it out and to go down to find the leaf node. If the leaf node value is the same as the target, then I delete that node.
Okay, got it.
Okay. I think, do anyone have any question for the iterative approach? Okay. So I think, so we could solve this problem by 2 approaches. One was the recursive and the second was the BFS with the queue. So what is the time complexity for the iterative way? Let's go reverse. So since we discussed the iterative way, the last, what would be the time complexity for this iterative approach and space complexity as well?
The time complexity would be big O of n, and
So
the space complexity will be the height of the tree.
So time complexity will be O of n because we have to traverse till the child to all the nodes, right? That's why it's O of n. The space complexity is height of the tree. Why is it height of the tree?
Yeah, it's the height of the tree.
Why is it the height of the tree? Can you?
Because at most, that's at most the number of node we save it in the implicit stack.
And okay, so that's for the recursive way, right? And what about in the iterative way? What will be the space complexity? Will you be saving all your nodes there in the queue? I think you will be, but so the algorithm, the way it worked in the queue, which was the BFS or the iterative way, was you were adding the parent to the queue, then you were getting the child and adding it back, if I'm not wrong, if I understood that correctly. So what will be the size of the queue?
I think the queue, the maximum space for the queue is the lowest level node number. Like the example 1, the node number will be 3 here. For the map, the space complexity is O of n. I have to store each node and its parent to the map. So the maximum space complexity for the iterative solution is O of n.
Okay, that sounds good. Any question here, anyone?
The other way we can do the iterative is to, for the post-order traversal, is to, do the same as the breadth first search, but instead of using the queue, we're using the stack. So we keep the node there, the parent node in the stack.
How will that work? Can you walk us through?
It's similar to breadth first search, right? But like we put the node on the stack. So first we see the parent, and then we see number one, the root number one, we put one on the stack, right? And then we go left, we see two, we put two on the stack, right? And now we go to the other two, and we see this two is it's a leaf, so we delete this node, right? And we go back to the parent on top of stack is two, so now we can process in that order.
So that's similar to recursion, right? Then?
Right, but we use the stack so that we don't do the recursive. It's kind of iterative.
Yeah, I mean, if you technically see, recursion does use stack in the background, but yeah, you can solve this that way as well. Okay, any other approaches? Any more questions on this? Should we move on to the next problem?
Yes.
Awesome. So the next problem is to find, which is again another sum from the medium sums. Find the smallest divisor given a threshold. So you have been given an array of integers nums, okay, and an integer threshold. We will choose a positive integer divisor and divide all the array by it, okay, and sum the result of division. Find the smallest divisor such that the result mentioned above is less than or equal to the threshold. Result mentioned above is nothing but the sum. Each result of division is rounded to the nearest integer greater than or equal to that element. For example, 7 by 3 is equal to 3 because 3 2s are 6 plus 1. You round it off to the next greater integer. And 10 by 2 is a whole, like there is no remainder, so it's 5. It is guaranteed that there will be an answer. So for example, you have a nums array 1 2 5 9 and the threshold is 6. So we have to find a number divisor, okay, such that you will divide each of these nums values of the nums array with that divisor, and you round it off to the next greater element, or if it is equal to that element, and you make a sum of it, okay? And we have to find the smallest divisor such that the result is equal to the threshold. So over here, if the divisor is 1, we get a sum of 17 because you just add the numbers. But if the divisor is 4, we get a sum of 7. And if the divisor is 5, we get a sum of 5. So the output is 5. Any questions on the sum, on the problem? We can look at more examples if we want to, but I just wanted to check. No questions? Has anyone?
Can you please explain how the divisor is 1 and then how the divisor is 4? I didn't get that part.
Okay, so we take one divisor at a time. Okay, so is there a condition on the divisor? No. So we choose a positive integer. So they have said that we will just choose a positive integer divisor. So it will start, so they have started with 1. Okay, and then you divide each number in the nums array with that divisor, which is 1.
Hello.
And add.
The voice is gone actually. Hello.
Hello? Can you hear me?
Yeah,
Hello.
I can hear both of you.
Hello.
Hello? Can everyone else hear me?
Yes.
Or is it
Yes.
just one?
Beginning.
Oh,
Yeah.
I think so. It's one person who couldn't hear, I guess. Okay, so I'll continue. Okay, there's some chat. Okay. I'll continue with the problem. So where were we? So we take the first divisor, that is 1. Okay, we divide each nums with the divisor 1 with the condition mentioned here to go to the, is rounded to the nearest integer greater than or equal to the element. Okay, and we get the sum as 17. Is 17 closer to the threshold? No. So we go for the next number, that is 2. Continue the same process. Is that closer to the threshold? Which the sum for 2 comes out to be 10. Maybe there is another number for 3. So you try with all the numbers till
Hello.
you reach, hello? So you continue with divisors such that you reach a value sum that is closest to the threshold. Okay, and you have to find smallest such divisor. That is why we started with 1, if it makes sense. And so that way we continue with, you try with 3, 4, 5. For 5, the sum turns out to be 5. For divisor 6, also the sum turns out to be 5, but we have to give the smallest divisor. So that is why the answer is 5. Is that clear, or should I?
Yes, it's clear. Thank you.
Okay, thank you. So anyone who has solved this problem? Any approaches? Anything that
The brute force approach is the one you mentioned, right? Just divide by 1 and divide by 2 and divide by 3 and see if it, closer to the threshold.
Yeah.
I mean, if we divide by 1, that means we're gonna get the really high number, right?
Yes.
If we divide by 2 and we get the smallest and the smaller, and then when we get it closer to the threshold, then
that's right. So does that. So brute force is you go through all the numbers. So, but as you said that the divisor reduces, a divisor increases, your sum reduces and gets closer to threshold. So does that hint you something? Anyone?
To improve the time complexity, we can use a binary search. The value could be 1 and the right value could be the maximum element in that array.
Okay, the maximum element in that array is 9.
Yeah, and use the binary search to find the mid element is half of the sum of the left and right. And to use the mid to be the divisor. Yeah, and to calculate the sum. If the sum is larger than the threshold, we will increase the left. Otherwise, we will decrease the right.
So your left is, you said, 1,
Mm.
and your right is 9.
9.
First of all,
Yeah.
let's begin. Like, first of all, why did you think about binary search?
Yeah.
How did you come to binary search?
Because as the person just mentioned, we can increase the divisor from 1 to 3 and find the sum is closer to the threshold. So that means to use the brute force, we can increase 1 by 1 to find the rate. Time complexity is O of m. So binary search can improve it to let the time complexity to O of log n. So I think maybe we can do the improvement.
Okay.
So that would be given if the array is sorted, right? Because the question doesn't say anything like that.
Yeah, the array is not sorted, but the divisor could increase 1 by 1. It's from 1 to 3 and until we find the divisor to be 5. That's the increasing array.
Does that make sense?
Yep.
Okay. So you said your divisor is the largest element. Sorry, your right. So we are doing binary search in that your left is it the index or is it the largest element? Sorry, the smallest element.
It's just from 1 because we can choose a positive integer. So the minimum positive integer is 1.
Okay, and the maximum positive integer is?
It's a max element in that array. For example, for example 1, we can choose right to be 9 because if the divisor is 9, the sum is just 1. That's the smallest threshold, I think, because 1 divided by 9, 2 divided by 9, 5 divided by 9 is also 0. Only the 9 divided by 9 is 1.
Oh, actually, if the based on the question, if we divide 1 divided by 9 equal 1, that's what I was right. 2 divided by 9 equal 1.
It's also 1. Yes.
It's 1.
Yes. So the sum will be 4.
This is the condition here.
Nearest integer, greater than or equal to. For this situation, maybe we can extend the right to be the sum of the array. I think that could be big enough.
So a right integer would be sum, which will be 14, 15, 16, 17.
Yeah, double check.
If we are dividing by the max element, okay, which is 9 here, okay, we divide 1 by 9, we get like some point something, we round it to the ceiling, which will give us 1, right? So if we divide any of this number by 9, okay, we are going to get 1. If we divide any of this number by 10, we are going to get 1 for each division. Okay, so I believe the max element S9 is the right choice. If you divide by 9, okay, what's the sum? 1 plus 1 plus 1 plus 1, 4. If you divide by 10, the sum is 4.
Yeah, correct. I also think, but if we if we want to find the max element in that way, we have to do all of n search to look into the array one by one and find the max element. There is another way. We can just set the right to be the maximum range, like the 1 billion or 1 million as the right value. Just put a constant value to the right.
Yes, and we choose that because like there is a constraint given in the question. Like below the examples, it says what can be the value.
Okay. But why do you choose sorry, why do you choose that number again? And why not the largest element, as you said?
But we don't know where is the largest element.
Yeah.
Because array is not sorted.
That's correct. Okay. So, yeah.
I solved in, I follow the same binary search approach, but in a different way.
Okay.
So what I did, first I found the first element, which actually possible result using the binary exponential growth. So I started with that 1, then 2, then 4, then 8, then 16.
Okay. How did you get these numbers? 1, 2, 4, 8?
So that's exponential. I'm doing the exponential growth. So I checked the 1, if it's a possible result or not, then 2, then 4.
Oh, okay.
So I found the first possible result and the previous value, which is not a possible result, and did the binary search in between those values.
Okay. So 1, 2, 4, 8. Okay.
So we are expanding every time by 2. Okay. Instead of like dividing every time by 2.
Yeah.
It's same as binary search, but this is called expanding binary search.
Okay. This is called what? Sorry.
Expanding binary search, where you start from the lower element and then like you start expanding twice instead of cutting in half.
Okay. Okay. I did not know about it. Okay.
I might miss it. Can you explain why, like, you have m minus 1 divided by m? Like on line number 8.
I solved this like almost a year ago, so I'm trying to think why I did that. I'm sorry.
That will give the ceiling. That's what C is doing there.
Okay.
It's a mathematical formula to calculate the divisor, like a division, which rounds up to the ceiling. Alternately, what you can do, you can take I, okay, convert it to the double, take M, convert it to the double, divide I by M, and then use math.ceiling to convert it to the upper ceiling. Like the ceiling, we can do that too, but this is like kind of a mathematical formula which gives the same result as the math.ceil function.
Can we give an example of that?
Does anyone of you, Gaurav or Roger, can?
Yeah, you can take like any. Maybe take 7 by 3, which is given like in the example. Okay.
7 by 3.
Yeah, just above the example 1. I'm just taking.
Oh, okay. Okay.
Yeah. So just to see like how it comes as 3, 7 by 3. Okay. So one way is to convert 7 into double, which is 7.0, and then like can you write 7.0 and then like divide by 3.0. Okay, and then whatever is the result, which is 2 point something, do math.ceil.
Okay.
Okay.
What the math.ceil?
Yeah, it will give you 3, and then maybe.
Okay.
Yeah. So, and the other way around is with this mathematical formula, you take 7.
Mm-hmm.
Like if you write in the next line,
Mm-hmm.
7 plus 3 minus 1.
Minus 1. Mm-hmm.
Yeah, which comes
Divided.
to, yeah, divide by 3. So which comes to 9 divided by 3.
Mm-hmm. Which is 3.
Yeah, which is 3. So
Mm-hmm. So there are various ways basically
yeah,
to
so you
calculate.
take like any other example, it will give result in the same math.ceil.
Mm-hmm. Was that clear?
Yes.
Uh,
Now for the sake of interviews, okay, I'm not
Mhm.
sure like if people can come up with I plus m minus 1 divided by m to figure
Mhm.
out math.ceil. So I believe it should be perfectly fine to convert those to the double and
Floating.
then do the division. Yeah.
Mm-hmm.
okay. Thank you.
Sounds good. That was a good explanation. So, any other questions?
I have a question about the selling math. It's a 7 plus 3 minus 1. Why we use the minus 1? If we don't minus 1, it's 7 plus 3 and the sum is 10 and it's divided by 3. The result is also 3. Why we need minus 1 here?
Take an example of 6 divided by 3. So I think it will be 3 then. 6 plus 3, 9 divided by 3.
Like over here.
Yeah, I know. It makes sense. Yeah, thank you.
Any other questions? No? Can we move on to the, what is the time complexity for the binary search approach? Anyone? No one? So we're going through numbers from 1 to the limit, which is 5 to 10 raised to 4. Can you guys hear me?
Yes.
Okay. So we're going from numbers and we are dividing into half every time. So that will be log of that number. Let's say that the highest number is k. So then we're dividing into half. So that will be log k. But then we also have to iterate through all the elements. So nums. So I think it should be n times log k. I think so. N times log k. What do you guys think? Anyone?
And what is k here? Like k is the range of.
K is the range of elements. Like you go from the highest element and then divide into half and then half and half. So k is the range.
Okay.
Yeah. So I think it is n log k or n whatever is the variable.
Yes, n times log k. And
Yeah.
also just wanted to add, like we talked about earlier that either
Expand.
like not expanding one,
Mm-hmm.
like how to figure out the upper range. Okay,
Mm-hmm.
which can be the maximum element.
Yeah.
Okay, so if we add like one extra for loop before performing the binary search,
Mm-hmm.
what's the time complexity of that for loop just to figure out the maximum element?
Can you repeat the question again?
Okay, so if we have to figure out the maximum element
Mm-hmm.
to find the upper bound,
Yes.
okay, what should be the complexity of the?
I think it is O of n, right?
Yeah, it's O of n, and
Yeah,
then
but in that case, when you are doing the sum, also we are doing it of O of n for each loop, right?
Yeah. So
So it should not be a big problem then.
Yeah, that's
Mm-hmm.
what I'm trying to say. We do O of n plus n times log of k, right? So which again comes as like n times log of k. So if we want to choose like a bigger number, like i e power 6, or even if we want to iterate through the array to get the maximum element to find the upper bound, okay, both will result in the same time complexity. Yeah, agreed.
Sounds good. Okay. Any more question on this?
I think we can move a little bit improvement in the for loop in the while. We can put an if condition here. If the sum is larger than the threshold, we can break the loop. Yeah, that means we needn't I needn't to iterate the whole loop if I found the sum is too large. Yeah. It makes sense.
So you're saying over here?
Yeah, in the for loop. In the for loop, we sum up all the elements in the noun. But I think during the iteration, we can put a if condition here. When we find the sum is too large, we can just break the loop and jump to the next condition. Yeah.
So then how do you know what is the value of your left and right? It will go into infinite, right?
We just find if the sum is and m minus 1 divided by m iteratively. And the sum is becomes bigger and bigger. If we find the sum is larger than the threshold, we can break the loop.
Okay. I don't think I understand it correctly. Can we?
Yeah, just think about the for loop. The for example, one we maybe we put the m as 5 here. That's the 5 is the correct answer. For example, we find 1 here, so the sum will be the 1 plus 2 plus 5. If I didn't put the if condition here, I have to iterate all the elements and get the sum. But when we iterate the 3 elements in that array, we already got the 8. 1 plus 2 plus 5 is 8. Yeah. Okay. At that time, we can break the loop and move to the next line. Yeah, that will be save some a little bit more time.
Yeah. Okay, I get what you're saying. Yeah, maybe that can help a little bit. I need to solve this and check if the logical, if it works. But yeah, something to try afterwards.
One thing I've seen, like sometimes what happens, there can be more than one result, which might be less than threshold, resulting in the same sum, like after we divide. So, but we want to choose which is like closer to the threshold.
Right.
Okay, so that's why like this loop will help. Like we will keep going up until to the very close to the threshold, and pick the one which is closer.
Okay. But does it say it has to be closer to the threshold?
Yes.
It just has to be smallest divisor.
Yes. So that's why like we don't break the loop. Like there is like no good example here, but there can be
Mhm.
two different divisors which can like result in the same thing. Okay, and it's still closer to the threshold.
Okay.
Because the perfect
Okay.
example was like so this is a binary search.
Mhm.
Remember, like maybe last week we did the same where we have to contain we have to ship like few shipments in D days.
Mhm.
And I believe the same question was asked at that time. I was like not very aware of that. So
Okay.
so there was like two different answers, 6 and 7. I recall vaguely, but one was like closer to what we want. So that is the reason.
Okay.
I guess like we can move on.
Okay. Okay. Sounds good. Any more questions on this problem? Is it okay to move on to the next sum?
Yes. Yes.
Okay, cool. My calendar 3, that's from the hard bucket. And I understood this sum a little bit, not completely, so I might need help here. So let's dive into the problem. So implement a calendar, implement a My Calendar 3 class. So to store your events, a new event can always be added. Okay, your class will have one method called book. It has two parameters, start and end. Formally, this represents a booking on half open interval. What is half open interval? Start and end, where the range of real numbers x is between start and end, inclusive of start, not of end. So it is between start and end, basically, including start. A K booking happens when K events have some non-empty intersection. That is, there is some time that is common to all K events. The example, I think they have my calendar 3.book 1020, which is the second line. And I think my calendar 3.book, that is 10.10, 40. They have a non-empty intersection. I think that's what they're trying to say here. For each call to the method myCalendar.book, return an integer k representing the largest integer such that there exists a k booking in the calendar. Okay, I did not understand this line very well. So if anybody understood this line, can come up. Or we can look at the example as well. Okay, cool. I'll just go ahead with the example. Hopefully the example, I'll repeat this line again. For each call to the method myCalendar.book, return an integer k representing the largest integer such that there exists a k booking in the calendar. So is this k same as this k is what my confusion was, all these k's.
So the K here is the maximum number of like the overlapping bookings at any given point of time.
Okay.
Okay.
So like in this example, let's take a look at the example. My calendar 3.book 10, 20. So there is just one booking. Okay. So then next time my calendar
Yes,
3,
at that point of time.
Yeah. Then we have my calendar 3.book 50, 60. So
Which doesn't overlap.
Does not overlap. So
Yeah.
we still return 1.
Yes. And
Why
then,
are we? So over here, since there is no overlap, it should be 0, or it's like does it mean that you can have 1?
Because like there are like no K bookings for the same slot. Okay, those two slots are different. Okay, and that what case K booking happens when K events have some non-empty intersection. Okay, so these two slots are not intersecting with each other. So we have still maximum intersection is 1 for each slot. Like each slot itself is a different booking, so it's 1.
Okay. Each slot is different.
Yeah. Now if you take the third one, 1040.
Yes. Yeah. So that intersects with the first one, that is 1020.
Right. So that's why the result is 2 there.
So we are giving the output is the intersection, the
Yes.
number of intersections.
The K, what are the K events, maximum number of K events which are happening at the same time? Just to
Hap-
like, yeah.
Yeah. So in this case, 1040 and 1020 are happening at the same time because their intervals are overlapping. So that is why the output is 2.
2. Yep. So we
Yeah.
up until when we process the first 3 events, we found that there are like 2 events which are happening at the same time. So which is at that point of time.
Okay.
Okay. And then
So the confusion starts here when you have
Yeah.
515.
yes, when
So
you
this is over. Yeah, go ahead.
yeah, this overlaps with what?
So this overlaps with 1040 and 1020.
Yes. So that's why like we get
3. So there are 3 events that are overlapping. Now you have 510, which is again overlapping with 1020, 1040, and 515. So the output should be 4.
See, like this event is not overlapping with the first one, because this event ends at 10, and the other event like which is on the very top 1020, it starts at 10. Okay. Because if you see, the end is not inclusive.
Not included. Okay. Yeah, right.
So shouldn't it be then 2 then instead of 3 because it's just being overlapping
It overlaps with what?
with 515?
Do you want to like?
Sorry, I didn't get that part. Why is it 3, not 4?
Okay, can I share my screen?
Yes, please. Let me stop sharing. You should be good to share. I stopped sharing. Sorry.
Okay, I'm just like drawing a table. Like, just give me a second.
Yeah, sure.
Okay. Can you see the table?
Yes.
Yeah.
So I just wrote like a table from 5 to 60. The only reason being that we have how many events? We have starting from 5 to 60. Max is 60. Okay.
Okay.
Now, what's the first one?
1020.
Okay. It starts at 10, ends at 20.
20.
Okay. So it goes from here to here, right?
It's going from 10 to 15. Oh, okay. So it's 20 starting point.
Yeah. So what I'm taking here is like this is the 10 as a starting point, 15 as a starting point, 20 as a starting point. Okay. Okay. I should have like one more column like maybe onto the left, saying 0 is the starting point for this one. Okay. So it will make more clear. Then 50, 60. 50 is the starting point, 60 is the ending point. Okay. 50, 60. Right? Then I have 1040. Then we have 515. Then we have 510. Then we have 25, 55. Okay. So looking at this diagram, okay, like what are the maximum number of events overlapping at any given point of time?
3.
3?
Yeah.
Right here? Okay, so that's why it's 3.
That's the output. Okay.
Awesome. Thank you. Thank you for the explanation.
Yeah, that was great. Thanks. Okay. So how will we solve this? Anyone who has solved this? So
I have one question, like why 5 to 10 is returning 3 instead of 2?
I'm thinking this should be 2.
Okay, let me share again.
It's just 1.
Yeah, stop sharing.
Yep. So what's the question?
The 510.
Okay.
5, 10, 1. It's returning 3 instead of 2.
No, so the problem says we have to, at any given point of time, we need to just have the results as like maximum number of events which are occurring at any given point in the system. Okay.
Okay,
So
so we need to maintain a max pointer for that, right?
max up, yeah.
Okay.
Okay.
Okay, so let me share that. Okay, so how can we solve this problem? So we are returning the max elements that can be booked, right? Max events that can be booked. How can we solve this? Any leads?
What should be the brute force solution?
Brute force would be every time you will have to find the intersection between the start and the end, right?
Yes. Yep.
So you have an interval, and then you will always mark your start and the max end limit,
Yes.
and your start limit as the lowest, and then you see if every new limit is contained within that limit, then you will increment your
Yes. So somehow like we
result.
need to somehow, as you said, we need to make sure how many events are intersecting. We have to
Right.
maintain that information. Okay.
Right.
And that's our answer. Now how can we figure that out? Can I share my
Well, yeah, sure. Go ahead.
Okay, yeah. So how we can figure that information?
So you have for the first event 10, 20, you have the lowest time interval. I mean, your start time interval is 10 and your max time interval is 20. So that your lowest will be 10 and your highest will be 20. So now when the next call is 50, 60, you realize that 50 is, so your lowest still remains 10 in this case.
So let me help here. So
Yeah.
what's the first event? First event is
10, 20.
20. Okay. What if I say I divide this event into 2 different events? Okay, 10 and 20. Okay, where 10 is the ending event.
Okay.
Right? Let me write it this way. 10 is the starting event and 20 is the ending event. Okay. Now, what are the other events? 50 as the starting event, 60 as the ending event.
Yes.
Right? Then 10, 40, 5, 15, 5, 10, 25 as starting, and then 55 as ending. Okay. So we got bunch of events, okay, that we have tagged as okay, something is starting, something is ending, something is starting, something is ending.
Right.
Okay. Now what if we sort them?
Sort on the basis of,
So what's the first index? Like it's just a time.
yeah.
Okay, at any given point, like when this event is starting.
Okay, the start.
Okay. Based on the time. Okay, not the start time, but like the time, because every event, either it is a start event or end event, now it's associated with the time.
Right.
Okay, so what should be the output here? We have like 5 as a starting event, right? Then we have another 5 as the starting event.
Right.
After 5, like what's there?
50 is the end though.
No,
Okay,
like don't
10,
worry about, like, we are just sorting this array. Let's say like this is an array and we are sorting it.
It will be 10, 10, and 10 again. 10 start, and 10 end.
Okay, so 10.
So every time we see a start event, we increment the count, right? And we see the end event, we decrement the count.
Yes, that's the goal. But like I'm trying to like sort based on the event. So we have like 10, 10, and 10. There are like 3 10s, right?
Right.
Okay. Now, what if the time is same, and I can like put all the ending events at the start? Okay, like for the events where the time is same. Okay, I need to put all the ending events at the start, because for any 2 given events, okay, either I can start first or end, or I can end and then start, because this 10 is not inclusive, right?
Right.
Okay, so similarly, like repeat the same process for all others. What's the next bigger number?
15.
15 is end.
End.
And then what's the next bigger number?
20 end.
Okay.
Then you have 40, I
25.
think. 25 start.
25 start, and
then 40 end.
40 end.
Then 55 end.
55 end.
Followed by 60 end.
We missed one. We missed like 50 start.
50, yeah.
50 start, and then we have 60
end.
end. Okay, now we got this sorted array. Let's say we have max event occurring at any given point of time as 0. Okay, and how many events we have like looked up until now? Okay, so what if we start both as 0? Okay, so 5 event is starting, right?
Right.
So we have count as 1. Okay, because when we process this first start event, like event is starting.
Yeah.
Okay, so we increment the count by 1, and then what's the maximum?
1.
Again, another event is starting.
Right.
Count is 2. Max is 2. Okay, event is ending. What count will become? 1.
1. Max is still 2.
Yeah, max will remain same.
Yeah.
Okay. Then again, another event is starting. Count will become 2. Right.
Right.
And then again,
10 start.
Is starting. Which is 10. Count will become 3. Max will become 3. Then one event is ending, which is 15.
15. So count is 2.
So count will become 2, because like that event end. Okay, then again one more event is ending.
25. No,
20.
20. Right.
Yeah, so count will become 1. Then again one event is starting.
So
count will become 2. And 1 start plus 1 2. Then again and 1 and 0.
Awesome.
Right.
Right.
So at any given point of time, now we know how many events were occurring. Okay, which is max 3 here.
Okay.
Okay. So this is like one approach. We can optimize it to do better, but if anyone have suggestions, please chime in.
Yeah, just as, I mean, for this approach, I would recommend to watch the video. Roger took a session on this Sunday to solve the range queries.
Yep.
Yeah,
so,
this is the event processing that Roger mentioned on that Sunday
yeah,
video.
I highly recommend to watch that session.
That will help. Thanks for recommending that.
What would be the runtime complexity for this one? And what data structure will be used to start the start event and end event? Because they're given, one interval at a time.
Yes. So what we can do to break it down? Maybe we need a time. We need a Boolean to mark it whether it is starting or ending. Right. So the way I did it, I just created a class called event with the integer time and Boolean whether it is starting or ending. A single Boolean called is a start or something like that.
Though I have not solved it, but what I'm thinking, I'm just thinking to have a dynamic array with the pair, with the two value.
Yes, we can do that too. If the language support it, like in Python, maybe like we can use a tuple with saying, okay, what's the time and whether the Boolean, whether it is starting or not.
But we can also use the tree, right? The tree, so that when we insert an event, that's only log n.
The tree map you're seeing in Java, right?
Yeah, it is mentioned in that
tree data structure, like
It is mentioned in the related topic, that segment tree, which I'm not very comfortable, but maybe that may help.
No, the granular tree, that's like a binary search tree, like we can insert the event in a binary search tree.
Okay.
Yes.
And then what we'll do?
Yeah, that's when you have an event, you insert the start event to that binary search tree.
Hello?
The same thing. Yeah, we can use the tree, and the values for that tree will be the start and end, and we can have a custom comparer to sort on the start.
Yes. Now given a binary search tree, okay, what we need to make sure like that tree is balanced. Or do we need to, or do we not need to? That sounds like a right approach. Binary tree sounds like a right approach to use.
Yeah, I mean, it should be balanced, then only you can get the best result.
Yeah, so how to like balance a binary tree? Binary search tree. Because binary search tree is itself like cannot balance.
So I mean, if we go with that language, so like in C we have a yeah, we have to, I mean, implement our own. I don't think so the language directly support that any balanced tree.
Or in Java, like maybe we can use tree map, which I am aware of.
But that will be hash table, right?
Yeah, it's kind of like a hash table, but a tree map has a property where it can give you for any given key, it can give you the key which is lower to that and the key which is higher to that.
Okay. Yeah. So in that case, I mean,
in login time, so that's a property of tree map, which kind of like mimic the binary search tree. But anyway, like yeah, so there are like multiple ways to solve the same problem. Like I recommend giving it a try, because in depending upon one or the other language, there might be something available which you can use directly, or there might not be. But my approach, like which I talked about, you can always create a tuple, or you can always create like a class with a time and Boolean, whether it is starting or not. Use any sorting algorithm to sort the array, and then it's just a simple for loop, iterating through all the events. Okay.
Yeah, that would mean every time you get a
they add the event, you have to do sort again and scan again.
Yes, that's the downside, but you can use a tree map to optimize it. Okay, like a binary search tree or something to optimize it. But what I'm trying to say, if for an interview purpose, if you're not able to come up with a solution with a tree map or binary search tree, this should be a good enough solution.
True.
Yeah.
Yeah, your explanation, Gaurav, was really good actually, and it is good to break down the problem and explain in the interview. Yeah, I like that.
Another method I'm thinking of is like to merge those events, right? So we have many events and we merge them. So, you know, now it become like a multiple event, no longer overlapping. It become every time become only one event, and then at each interval we can keep the count.
I'm not pretty sure like that will work cause like we can still merge multiple events. Okay, and
I think if I understand correctly what he meant that, I mean, whenever we add a booking, so at that time we do some processing and and update keep that information. If there are two events, they are already overlapped. So we don't need to verify that next time. We know that they are overlapped and we can keep the count, say like these two events are overlapped. So count is for this range, there is a count for two.
Yes.
So take this example, like if you see my screen, okay, these two events, like which are at these two rows, they are overlapping with each other. Okay, and this event is overlapping with only the event which is in the middle. Okay, and then upper event is overlapping. So given that the way like we talked about, are we going to merge all these four events?
We merge the events so that now we have only one single, I mean, not one, let's see. We no longer have overlapping. Whenever we see overlap, we merge them.
Okay, so in this case, like take this example, we merge these two events which are highlighted on my screen. Can you see my screen?
Yep.
Oh, yeah, I'm driving, I cannot see.
Okay, so we can merge this one and then we merge this because this is overlapping. And then, so we have three overlapping events which we merge into one. Now, this one is overlapping with the complete overlap here. Okay. But like post your solution, we can discuss on the Slack because as you're driving, I'm not sure like it's more helpful.
Yeah, okay.
Yeah, that sounds good. Great explanation, Gaurav. Thank you for that. I think I will also solve this and post it on our thread for the problem set today.
Yep. Thank you, Smita, for hosting the session.
Okay.
Thank you.
Yeah.
Thanks, Gaurav. Thanks, Smita. Yeah. Thank you.